volcanoes are formed in snow in the same way they're formed anywhere else on Earth. As you will or have already learned from our videos today, the way that volcanoes form has to do with magma coming up through the crust, and that can happen anywhere on the Earth's crust, near where tectonic plates meet. So if you haven't yet watched the video about tectonic plates and continental drift, that will show you how when one plate dives underneath the other, it melts into the magma, and that magma, because it's more liquid and less dense than the more solid magma deeper, it rises to the crust and comes up and forms a volcano. The snow is on the surface, and while the really main result it would have is cooling the lava faster once it reached the surface because of the difference in temperature. The caption of this picture says, "A steamy scene. When extreme cold meets extreme heat, the result can be unpredictable phenomena." Phenomena is like interesting things that spark our curiosity. In some instances, as lava pours over snow, meltwater trickles down between the ice crystals. This results in a steamy river flowing from beneath the snow and ice. "This picture was taken in the middle of a snowstorm," said Edwards, who added that the stream was between 104 degrees Fahrenheit and 122 degrees Fahrenheit. So that's like jacuzzi temperature. So it's hot, it's melting the ice, but making the water really hot. It says 1,000-degree rivers of molten rock, like the lava smothering or covering an older snow-covered lava flow in Kamchatka, Russia, pictured above, and hissing snow are just another day in the field for Ben Edwards, a volcanologist at Dickinson College in Pennsylvania. He studies volcanoes covered with snow and ice to figure out how previous ice ages have come and gone and how Earth's climate has changed. Sediment cores, that's when the geologists take and drill deep into the ground, and they pull up this long kind of rod of all the layers of soil beneath the surface of the Earth. I can actually show you one sometime. We have one when Hillbrook, when we built a building, the new multi-purpose building, the geologist did a sample core or a sediment core of the ground underneath that building, and we have it. And the geologists make a prediction about how old the sediment is. Obviously, the deeper you go, the older the sediment is, and you can find and study and learn interesting things based on what you find deep in the soil. So in this case, sediment cores, the core sample is what I just explained, from the seafloor do a good job of recording ocean temperatures, which went up and down over the stages of glaciers over the last thousands and many thousands of years. But the record gets muddy once you start looking on land. Many volcanoes have erupted under glaciers over the past several million years, he said, and those deposits are the only deposits left that indicate the presence of ice at the time of the eruptions. By studying the results of actively erupting volcanoes covered with snow and ice, Edwards can learn what to look for in older lava flows that actually came out where the lava actually flowed onto the top of glaciers. Sometimes lava flows plow against a snowbank, carve out caves within a glacier, or slip underneath the ice. In Russia, we saw everything, Edward said. We saw lava flows start to burrow under the snow, creating pileups. For instance, researchers saw a lava flow push up a dome of snow that rose 7 to 10 feet into the air. The surface started to crack and lava started to peek through, Edward said. Heating blanket. Volcanic ash, the gray sandy material pictured, can act like an insulator. An insulator is something that keeps the temperature inside the same and doesn't allow a lot of change. So it's like when you put on a jacket, it insulates you from the cold temperature outside and keeps your heat inside. So the volcanic ash can insulate the underlying snow from the lava flows, Edward said. That's why you don't see any steam in this photograph, he added. There are cases where blocks of snow have been preserved for decades, if not longer, in these kinds of conditions, he said. Once you get 5 to 10 centimeters of ash, it's a pretty effective blanket, he explained. In Kamchatka, Russia, tourists guided by a park ranger on the far left, so that's the man in the brownish jacket on the left, view a channel of molten rock flowing down a canyon in older lava deposits in Kluchevskoy Nature Park. Understanding how lava reacts with snow and ice is also important for predicting potential hazards or things that might be dangerous to people in the area, said Edwards. This park saw a massive eruption in the 1970s, a volcanic eruption, which destroyed a couple of huts used by park tourists. So they want to be able to understand more so that they can predict what will happen in the future and maybe save people that might be in nearby towns as well.